This interactive user profile analyzer goes into how a text input is used to generate a contextual profile and how the contextual data could be encoded and compressed using quaternions and rotary positional embeddings. Different machine learning models excel in different ways in contextual awareness. A way to use different LLMs via API keys is included. Let's go into how this profile is generated. AI models don't just understand text like a human. Instead, they use mathematical techniques to find patterns, relationships, and structures. The core concepts are text vectorization, called embeddings, that convert words into vectors. Topic modeling takes pre-trained data sets and categorizes the vectors into weights. Then transformer architectures take these and form a self-attention mechanism for predictive analysis. Rotary positional embeddings use transformers to encode positions by rotating vectors, using rotary mathematical concepts which mimic pure mathematics. RoPE's goal is to make similarity calculations dependent on relative distance by taking two rotated vectors dot products. This allows mesh systems to be developed, maximizing use of latent space. The contextual mapping is where the work comes in. Creating the framework to assign contextual weights is an ever-evolving art. This demonstration uses quaternion rotations to represent contextual information. By dividing a preset grouping of contextual information, we can assign different agents to analyze different quaternion groups in parallel, while processing them all through a single time frame. This offsets the time to space calculations in a way that enables high-density encoding into single-cycle computations. The Q-final quaternion would encode all contextual areas in one complex set and require one computational cycle to transmit all this data. Decoding would require existing state knowledge of context, embedding security in the design.